People often discuss large language models existing in one of two states. Either the machine is an infallible genius, or it is entirely broken. This diagram illustrates how these models actually operate. They slide along a spectrum of cognitive complexity. The reliability of the output depends entirely on the specific constraints of the prompt you feed the system. Educators have measured this exact shift in cognitive demand since the 1950s, using a framework called Bloom's taxonomy. It categorizes intellectual work in stages, from simple memorization up to complex original design. When automated systems crash or hallucinate, it is usually because developers are using rigid, low-level instruction structures to ask a model to perform highly complex, subjective reasoning. This diagram maps the taxonomy to machine operations. The bottom three tiers, remember, understand, apply, represent low cognitive load, strictly retrieving existing information. The top three tiers, analyze, evaluate, create, require the system to weigh evidence and synthesize novel ideas where no single correct answer exists. Building autonomous agents capable of navigating these distinct levels requires highly specific architectures. Imran Anand's book, 30 Agents Every AI Engineer Must Build, provides the exact blueprints for mapping AI agents to these distinct tiers. Mapping the correct prompt structure and agent design to the right rung on this ladder is the absolute prerequisite to designing a system that does not confidently invent false information. The bottom three tiers form the verifiable zone. The user needs a specific fact, and any deviation from that fact is an error. We want zero creativity here. This diagram shows the data flow controlled by the system's temperature. Temperature is a setting that determines how strictly the AI chooses the most mathematically probable next word. For verifiable tasks, engineers set this dial near 0, forcing a highly predictable, linear output. We pair that 0 temperature with a prompt structure known as a fence. The instructions forbid the model from guessing, restricting output strictly to provided reference documents. You see this configuration when automated systems convert legacy code libraries or extract dates from corporate compliance policies. At this level, risk is entirely procedural. If the model makes an executional error, standard software testing will easily catch it. This diagram illustrates what happens when we move to the top three tiers. The output space exponentially widens into an array of thousands of subjective, equally valid possibilities. To operate here, the system temperature must be raised. This flattens the statistical probability curve, allowing the model to bridge distant, previously unconnected concepts to generate novel ideas. But this introduces the risk of unverifiable plausibility. The model prioritizes statistical flow over factual accuracy, producing a logical flaw that reads perfectly and bypasses automated surface-level testing. Fences fail at this altitude because there is no single right answer to fence the model into. Instead, we use scaffolding. Techniques like chain-of-thought prompting force the system to write out its intermediate logic step by step before arriving at a conclusion. If you ask the model to evaluate a complex strategy, the prompt must explicitly demand that the machine state the exact criteria it will use to judge the data before it issues a verdict. Peak performance at this tier requires multi-agent setups. You divide the labor, assigning one agent to generate a creative solution and a completely separate agent to evaluate that output against strict parameters. As cognitive demand scales upward, your instructions must evolve from a restrictive cage into an auditable, transparent reasoning structure to survive the risk. Biological human learning follows a strict upward path. A person internalizes basic facts, understands the mechanics, and learns to apply the rules long before they attempt to create an original, complex design. This diagram shows how generative systems flip the process upside down. The machine instantly synthesizes a final draft, dropping the human workflow at the top. Because generation happens instantly, the operator is forced downward into middle tiers, analyzing logic and evaluating the machine's structural choices. The primary professional value of human labor in this environment is no longer generating raw content. The value comes from acting as a highly skilled, expert auditor of statistical logic. This inversion triggers the novice constraint. To properly audit an artifact generated by a machine, the human reviewer must possess a deep, pre-existing mastery of the subject matter. These models produce output that is grammatically flawless and extremely confident. This linguistic polish creates a highly dangerous illusion of competence, hiding deep structural errors. The safety of these deployments depends entirely on whether developers are building prompt architectures that precisely map to the cognitive risks of the specific task at hand. To explore the mechanics behind advanced generative architecture and system design, subscribe to the Neurals.ca channel. To construct these highly resilient, multi-agent hybrid workflows for yourself, pick up a copy of Imran Ahmad's book, 30 Agents Every AI Engineer Must Build.